Alright, stream should be starting. Alright, everybody. Welcome back for the fifth and final day of the AWS Certified Developer Bootcamp. We're going to wrap up on the topics of Cloud Formation, shared responsibility, and Route 53. So, before we get started, were there any questions? I know yesterday we talked about VPC, which is a very hefty topic, and there's a lot to it. So, if there are any questions, we can handle them now. Joe, is the stream up?
It's up, and I can hear it.
Okay. Is it on? It's on the slides?
Yes.
Okay, cool.
I had a question on like the availability zones and like the EBS
Okay.
stuff, because it's saying like, I think I read something that the EBS, if it's tied to the EC2 instance, they both have to be in the same availability zone. Is that right? And if so, do you have control over what availability zone, or does Amazon control that?
They certainly have to be in the same region.
Mm-hmm.
For the availability zones, I believe that's the case, and yes, it will ask you where you want it to be at, because it has to be able to attach to that EC2 instance. So think of regions as totally independent from one another, and then availability zones are networked together.
Right.
So they are separate physical data centers, but they act more like one, but they're all networked together.
Okay.
And yeah, you need to be able to attach that EBS volume to your EC2 instance.
Mm-hmm.
If it's per availability zone, I'm not sure, but I definitely know they have to be in the same region.
Okay.
So, and that's something I can look up and get back with you on for that. But yes, oftentimes you do get the choice in which availability zone you want to put something in.
Oh, really? Okay.
Mm-hmm. And actually, on the vein of availability zones, if I have an AWS account and you have an AWS account, and you're looking in US East 1, so Virginia, your availability zone A may not be the same as my availability zone A.
Oh.
So those are actually different per account, and those are like randomly assigned. So it helps to spread traffic out, because not everybody's availability zones would be the exact same. So, any other questions? Okay. If there are no further questions, then let's jump into Cloud Formation. So, what is Cloud Formation? We got a video to watch, and then we will talk about it.
When you're managing infrastructure, maybe you're using runbooks and scripts to create and manage everything. Version controlling and keeping track of changes can be challenging. Things get even harder when you need to replicate your entire production stack multiple times for development and testing purposes. But provisioning an infrastructure stack directly from a collection of scripts isn't simple. Wouldn't it be great if you could create and manage your infrastructure and application stack in a controlled and predictable way? Introducing AWS Cloud Formation. Cloud Formation provisions and manages stacks of AWS resources based on templates you create to model your infrastructure architecture. You can manage anything, from a single Amazon EC2 instance to a complex multi-tier, multi-region application. Cloud Formation can be used to define simple things like an Amazon VPC subnet, as well as provisioning services such as AWS OpsWorks or AWS Elastic Beanstalk. It's easy to get started with Cloud Formation. You simply create a template, which is a JSON file that serves as a blueprint to define the configuration of all the AWS resources that make up your infrastructure and application stack. Or you can select a sample pre-built template that Cloud Formation provides for commonly used architectures, such as a LAMP stack running on Amazon EC2 and Amazon RDS. Next, you just upload your template to Cloud Formation. You can also select parameters such as the number of instances or instance type if necessary. Then, Cloud Formation will provision and configure your AWS resource stack. You can update your Cloud Formation stack at any time by uploading a modified template through the AWS Management Console, command line, or SDK. You can also check your template into version control so you're able to keep track of all changes made to your infrastructure and application stack. With Cloud Formation, you can version control your infrastructure architecture the same way you would with software code. Provisioning infrastructure is as simple as creating and uploading a template to Cloud Formation. This makes replicating your infrastructure very simple. You can easily and quickly spin up a replica of your production stack for development and testing with a few clicks in the AWS Management Console. You can tear down and rebuild the replica stacks whenever you want. Replicating a production stack could have been time-consuming and error-prone if you did it manually. But with Cloud Formation, you can create and manage AWS resource stacks quickly and reliably. And there's no additional charge for Cloud Formation. You only pay for the AWS resources that Cloud Formation creates and your application uses. To get started, visit our website and launch your first stack with AWS Cloud Formation today.
All right, Cloud Formation. Infrastructure as code. So this is scriptable infrastructure. This is one of the 3 provided tools that Amazon gives you for deployment and managing environments. So we've talked about Elastic Beanstalk already, which was kind of an introductory service to get you into the cloud. Then we've not talked about, but one of the others is OpsWorks, which is a Chef implementation hosted in AWS. And then finally is Cloud Formation, which is the most advanced. And that is scriptable infrastructure. Cloud Formation is used to allow for consistent and reproducible creation of infrastructure programmatically. Implementations of templates are called a stack. So let's say that we have a production environment that we want to host. We may want the ability to spin up alternate versions of that for testing or development. We may want to have it on hand if we needed it in a DR recovery sort of scenario. And if you were to do all this by hand, it could be error prone, it could take substantially longer, and it could be a lot more difficult to maintain. But when you spin up a stack through a Cloud Formation template, all the resources exist under this stack, and it'll allow you to create or modify or delete those resources in the stack all in one place. There are 2 formats that the templates can come in. They are JSON and YAML. JSON was first, and then they introduced YAML. Stack operations that you can do are creates, updates, and deletes. Now, when you're bringing up or updating a stack in Cloud Formation, if your stack or update fails, then the stack will roll back to the last stable state. So, and this is an important thing to remember, is if I have created a stack and maybe I want to trigger an update, I've added maybe a new EC2 instance that I want to have get deployed with my stack. But when I trigger the update and it fails, say that I had not just an EC2, but I had a couple different resources that I was doing. All resources that were part of that update would be rolled back to the last stable state. So it will always roll back to what was stable. Now, if it's a new creation and it fails, it will roll back to nothing. The stack will still say that it was there. It'll still say that the create failed, but the stack will look like it's there, but there will be no resources in the stack. Does that make sense?
It's like a transaction, either all or none.
Yeah, it is like a transaction where they don't want to leave you in a state where you are stuck in a place that's kind of a halfway, potentially not working environment now. So they'll either do the whole thing or not at all. Okay, so within a Cloud Formation template, and if you've got your packets, look at, I think it's the second to last page. Should see a document in there. And at the top it should say AWS template format version. Does everybody see that? Okay. For those who don't have this, I will send this out with the slides later today. So this is an example template that I found on GitHub from AWS Labs, account that AWS has out there. And it's I want to say that they're spinning up a VPC. I don't remember, to be honest. But go ahead, and this is kind of a have on hand example to see what it looks like. This is in YAML, by the way. So there are sections in a CloudFormation template. There is the AWS template format version, and this is the version of the CloudFormation that is being used. Then you have description. So it's a description of the stack. So when you bring this up and you spin up a stack in your console, this description will be what's displayed next to the stack name so that you know what it's for. You can have metadata. So these are JSON objects or YAML that provide details about the template. You can have parameters. Parameters are requests for values to help make your templating dynamic. So if you were to add parameters in the parameters section during your stack creation, these parameters would need to be filled out by a user or in order to spin up resources, and this allows you to do it dynamically. Mappings. Mappings are key value pairs that store and allow you to access data in the script. Conditions. These check for values used for flow control. So maybe I create a parameter that says, is this a dev stack, a QM stack, or a prod stack? And in my conditions section, I might say, if this is dev, then use the following 3 images from the mapping section. Or if this is prod, use different ones. So I can control what my stack is building dynamically based on the parameters and the mappings and the conditions. Resources. This is the only required section of a CloudFormation template. And this is where you would create your resources. These are either your JSON or YAML objects. And then outputs. And this is a section that you can use to make values available to users after the creation of the stack. So I might say, I want to create a RDS. I want to create a database in my CloudFormation stack. And then I'm going to need the path in order to log into that RDS instance. I could use, since I don't know what the URL to this RDS would be beforehand, I would use CloudFormation and spit it out in the output section in order to get that URL. So far, so good? Okay. There are functions in CloudFormation that help to control the flow and help you to get information within a CloudFormation template. You don't need to know exactly what all these are, but have an idea of what some of these are and what they can do for you. So we're going to talk about intrinsic functions, and these are internal functions to retrieve or work with data internal to the script. So one of them is FN, or function, get attribute. And this will allow you to dynamically get an attribute of a resource at runtime. So you might reference somewhere else in your script. Let's use an example of, I have created an EC2 instance and I want to register it into an auto-scaling group. I could use the get attribute in the instances section for the auto-scaling group in order to add that dynamically. So I don't need to know what it is. When CloudFormation spins up that resource, it knows what it is, and then it will drop the proper value in its place. There's the function find and map, and this returns the value of a key value pair that is specified in the mapping section. So one instance or one example that you might want to use with this is you may have AMIs for EC2 instances that you want to spin up, but because an AMI is specific to each region, you may want CloudFormation to detect what region you're in and then pull the proper AMI image based on the region. So you would list out the region name maybe as your key, and then your value would be the AMI name, and then you could use a function to get what region you're in, and then it would go and pull the proper AMI image. fn join or function join. This concatenates elements by a specified delimiter. So you might use this to build out paths dynamically. Ref or reference. This returns a resource based on the logical name or the name given to the resource in the resources section. So I might give a name to an object that I've built as a JSON object called my instance. And I could use the ref tag to drop that resource in for another object that needs that information. There's the function getAZs, and this will get a list of the availability zones for a specific region. fn select, which will select a single object from a list. And that's it for what we're going to cover with functions. That's just to give you guys kind of an idea of what can you do with Cloud Formation. It's important to just remember that it can be either a JSON or YAML template that you use to spin up and create infrastructure consistently and easily. And that you can do things dynamic in Cloud Formation with using parameters and functions and different aspects that Cloud Formation helps you to do those things. Does everybody follow? Okay, any questions? Cloud Formation is a very deep subject, but it's not covered super deep for the developer exam. But if you do go forward with some of the other exams, expect to go a lot deeper with Cloud Formation. And Cloud Formation is a great tool to have in your tool belt. Question?
I don't think your screens are switching again.
Really? Okay.
Because we're still on the section screen. The one right before this last one.
All right, it should update here in just a second.
Okay.
Question?
Like when you create a template, can you using a component of other template to make a new template?
So
kind of like a Lego. I have a separate template. Somehow I want to combine them in a certain way.
So the question was, can you use elements from another template? So cross the resources between templates in order to build upon them. Is that correct? Yeah, that's a lot more of an advanced feature. What you can do is you can use the parameters and output sections, and you can actually use the outputs of one script as the parameter values of another. And so you can create like sub CloudFormation templates in a larger one and reference them. Mm-hmm. And so it's kind of like a Lego effect, like what you're saying is, for instance, an example that would be that I've done a multi-stack template before, or a sub-stack, where I had one template would go out and create my VPC, another would go out and create my security groups, and another would go out and create my EC2 instances. And I would coordinate them all under like a master stack, and they would be able to build upon each other from there. And the nice thing with that was I could reuse things like if I created a generic VPC, I could use that script in multiple different locations and not have to reinvent the wheel, so to speak, and rewrite that. So yes, you can use multiple scripts together in order to create more like verbose CloudFormation stacks.
So in other words, the template is reusable.
Yes, templates are reusable. In order to reference something from another stack, you would need to like pass it into the parameters section.
Okay.
So it's not like you can just jump into another stack that doesn't have that outputted already. So you need to like have a parameter to accept those values. With the example of the VPC, when the VPC would come up, I might spit out the subnets, the information about the subnets and the VPC ID, and then I would use those to pass into my other scripts so that I knew where I could put my EC2 instances at.
Okay.
Does that make sense?
Yeah.
Good question. Any other questions?
We have a question from the AWS channel today, and it is, when do we use cloud formations versus Elastic Beanstalk?
Okay, so the question is, when do we use Cloud Formation over Elastic Beanstalk? So Elastic Beanstalk is a great tool if you are unfamiliar with how to script out the infrastructure. If you're less familiar with AWS, or potentially even if you're not interested in dealing with the infrastructure at this point in time. Beanstalk manages a lot of these things for you. However, since Beanstalk manages a lot of this for you, you have less control over what you can do. CloudFormation is the most advanced of the 3 deployment tools that Amazon provides you, but it also gives you much more control over what you can do. So an example of something that CloudFormation can do that Beanstalk cannot would be custom resources. And this is much deeper, but this is a great feature of CloudFormation that makes it very powerful, is if there's something that you can't do implicitly by CloudFormation, you can create what's called a custom resource that will trigger something like a Lambda, and it will go out and make a special call to do what you're trying to do. An example would be one that I've done before. I had a CloudFormation script that would spin up an environment, but I also using sumo logic. And I had Kinesis streams. These are a streaming service. It's not part of this exam, but it's streaming data. And I needed to hook my streams. I'm sorry, I was using S3 for this one. I had a Kinesis stream that would dump in my logs into an S3 bucket. And then sumo logic has what's called a collector. And it goes and it looks in an S3 bucket for records. And when it finds records, it brings it into sumo logic for monitoring. But I needed to create the collectors in order to link them to my S3 bucket. And since each stack changed, they were never the same. So I created a custom resource with a Lambda that would go into sumo logic's API. I used the intrinsic functions to pass in the values I needed to my Lambda function, and I would create through that custom resource the collectors in sumo logic through their API. So you have a much more fine-grained control with CloudFormation, but it also requires a lot deeper knowledge and understanding of the infrastructure of AWS and of what you're trying to accomplish. Any other questions? Okay. We are going to move on then to the shared responsibility model. And this is pertaining to what is Amazon responsible for in AWS and what are you responsible for. So it's important to understand where is Amazon's responsibility for things and yours. So, shared responsibility model. Understand who's responsible for managing what in the cloud. For instance, Amazon is responsible for physical hardware, managed services, virtualization infrastructure, and network infrastructure. So, Amazon is responsible for securing their data centers. Amazon is responsible for making sure that the physical hardware is up and running properly. They're responsible for any services that they have said that they've managed. So things like Dynamo, things like Lambda, these are managed services. You don't need to go in and patch a Lambda function. You don't need to go in and patch a RDS table, or I'm sorry, a Dynamo table. These are levels of responsibility in which Amazon has taken on. So there, if you called up Amazon and said, I want to make sure that your data centers are secured, they're going to tell you, no, we're not going to walk you through. They handle that. What you are responsible for, however, is things like operating system patching on your EC2 instances, data encryption in transit and rest. That is very important. They're not going to encrypt your data for you. That is on you. Images, AMIs, snapshots, database snapshots, EBS snapshots. These are your responsibility. Users and credentials. These are your responsibility. Amazon does not restrict the users that you can create. So you need to be careful because you need to manage your AWS account properly, or you can kind of hang yourself with it. So, but it is important to know what is the responsibility of you and what is the responsibility of Amazon. I've added a link as well for some further information about the shared responsibility model. Any questions? Yes?
Does images mean digital pictures, or does it mean like a disk image?
Images such as like AMI machine images, or like database snapshots, right, or EBS volume snapshots. So images would be like objects in S3, and you're responsible for encrypting them and handling those two. But you don't need to make sure that S3 has enough space for you to store your information on. That's managed by them. But what objects you put in the bucket is on you.
Including digital images, if you want
Like pictures?
Yeah.
Yes. Amazon just sees those as objects.
Okay.
So, any other questions? Okay. We're going to jump into our last topic, and that is Route 53. So, Route 53 is Amazon's hosted DNS service. This is where, I don't know if anybody's used a service like GoDaddy or any other web services that you could buy a domain. The Route 53 is Amazon's version of that. So you can go in, you can purchase domains, you can create subdomains, you create your DNS routings for those domains. So there are several routing types. I'm highlighting 4 of them because these are the most important ones for you need to know on this exam. And that's A records or address records, which are IPv4 addresses, CNAME, and I can never pronounce this right, but canonical name. I probably butchered that horribly, but
Canonical.
Canonical, thank you. This is mapping to another DNS address. MX, which is mail exchange, or AAAA, quadruple A, which could be an IPv6 address. Okay, so let's say that I have created, let's draw this on the board. Alright, make sure that the camera comes up, please. Alright, say that I purchase a Route 53 domain for Steve site, if I can spell, .com. Alright, I've purchased stevesite.com. This is my domain. I can have subdomains under this, so I could have api.stevesite.com.
It hasn't switched yet.
It's not switched?
No. Sorry. I counted to 15.
Okay. Should be now. Well, this is just a DNS entry. So same thing with this. They have to point to something. So let's say that I have a web server. I have an EC2 out there, okay? And this has a public IP. LIC. Has a public IP address. I want, instead of having to go to 172.84.96.83, and that's not a real IP, but that's okay. I don't want to send my users from my website to my IP address. I want them to go through my DNS record. So I would point my DNS, so it's actually more this way. When people hit my DNS, it resolves down to my IP for my instance. So if somebody was to go to stevesite.com, it would route them to this instance, and I would serve my traffic from there. Now, let's talk about load balancers. Let's say that I have an ELB, because I might have multiple web servers. EC2, EC2. Say I have 2 EC2s under my ELB, correct? Now, in this case, we're pointing to an IP address. So what kind of routing type would we use for this?
A record.
Yep, we would use an A record because we have a IPv4 address. But with our ELBs, do you guys remember what we said about ELBs? If I want to do this instead, can I get the address or the IP of an ELB? No. All right. So if I cannot get the IP of an ELB, because this might be my ELB.aws.com. That might be the DNS record that the ELB is providing me with. How do I link this to my Route 53 entry? What type would I use?
CNAME.
Yep, you'd use CNAME, except in AWS, you can use A records for ELBs because under the hood, Amazon is going to resolve down to the IP 192.168.56.84, whatever. So where you almost always would need to use a CNAME because CNAME is what's going to resolve that DNS and then point to use. It's like a kind of like a pass along. So I'm using a DNS to go in and resolve another DNS. That would be what a CNAME does. But since Amazon knows what this is, even though they don't provide it to you, they let you use an A record. And that'll actually save you a little bit of money because it doesn't have to go in and resolve what the other DNS was. Does that make sense? So it's important to know, if you see on your exam that you're attaching an ELB to a Route 53, make sure that you use A records, not CNAMEs. Otherwise, if you were trying to resolve to something other than, you know, another DNS record that was not an Amazon service, because Route 53 is not just specific to what you have in your AWS account. You may have another DNS that you wanted to route to, and you would have to use CNAME for that.
So is that the IP address of the ELB or one of the EC2s? Is it?
So in this scenario, we're routing here. We are coming across and we're attaching this as an alias record. So we would say that this is an A type and the alias is this. And it would go in and Route 53 will resolve this. We have no way as users seeing this. Under the hood, because we're specifying that this is the alias for an A record, Amazon under the hood resolves this.
Okay.
Does that make sense?
Yes. So where do we enter in?
We would, so you get a drop-down box,
Right.
and in that drop-down box, you would select the DNS for your
Got it.
ELB, but you
Okay.
specify, there's a spot where you say, is this an alias record or not? And you'll say, yes, this is an alias, and the alias is the DNS of my load balancer.
Okay. Got it.
Follow?
Yep.
Okay.
Could you use the CNAME if you wanted to?
Yes, you could. You could use the CNAME, but you would be potentially incurring more costs because it has to resolve what that DNS is.
Okay.
Other questions? Okay. So, next we're going to talk about routing types. Okay, that should have switched. It did not switch, did it? Okay. Routing policies. There are 5 routing policies in Route 53 that you need to be aware of. I need to understand these. So there is simple, which allows you to route traffic to a single specified endpoint. Weighted, which allows you to route a specified percentage of traffic to multiple endpoints. Latency, which allows you to route traffic between multiple endpoints to the endpoint that will take the least amount of time to receive the request. Failover, which allows you to create health checks to ensure the health of an endpoint, and if that health check fails, to reroute traffic to another endpoint. And geolocation, which allows you to route or block traffic based on an origin country of the request. Okay, so what does all this mean? All right, so the first type that we'll talk about is simple. And then let's say that I have my Route 53 of stevesite.com, okay? And I'm going to use type simple. And what this is doing under the hood is saying, okay, Route 53 entry, I have a EC2 instance. Route me there. So whenever I get a request to my DNS, it sends me straight to my EC2, or my ELB. And this is still a simple routing. Even though the ELB is routing to multiple EC2 instances, the endpoint for the Route 53 is the single endpoint for the ELB. Does that make sense? Okay, weighted. Weighted allows me to send to multiple endpoints. So, let's say that I have an EC2 here and an EC2 here. I may say that this is my old instance, and this might be something I want to test out. This could be maybe a new interface that I have that I want to kind of try out with new customers, but I don't want to swap all my customers over. I just want to have some of my traffic get routed over. So let's just say this is my new instance. I might say that I still want 90% of my traffic to continue to go to my old EC2 or ELB. It doesn't matter. ELBs and EC2s, they're both just an endpoint, so they work the same. And I have 10% of my traffic going to here. So 9 out of 10 requests will go to my old EC2 instance. But 1 of the 10 will get routed to my new one. Question?
Why would someone want to set up something like that?
So one scenario is maybe they want to restrict how many people are going to see the new interface and they want a random sampling. You could do that. Or this is a really big topic when you get into deployment models with blue-green. So I'll cover that just real highly. A blue-green deployment is where I spin up or I create 2 stacks and I'm seeking to replace my old stack with my new stack. And the idea is that there is 0 downtime and that if there's any failure with the new stack, I can just point back to my old stack without having any downtime. So this is very important when it comes to a blue-green environment. So let's say I have one environment here, and let's say this is I have an ELB here, and it has EC2s, and this is my old, and then I have an ELB here, EC2 and EC2, and this is my new. So ELBs can manage large amounts of traffic, but also they can't get slammed all at once. If you needed to have your ELB handle a ton of traffic right off the bat, what you could do is call Amazon and ask for them to pre-warm your load balancer. This introduces an issue when we are doing a blue-green deployment, where we might have a very active production environment, but it takes time for our ELB to build up to be able to handle the amount of traffic that our production environment is currently receiving. So what we can do in a blue-green scenario is with our old, I might say I want 90% still and 10% now, starting to go to my new environment. And then maybe after 10 minutes, I then switch that to 75, 25. And then maybe I go from there after another 10 or 15 minutes to 50, 50. And then 25, 75. And then 0, 100 when I'm sure. So this serves 2 purposes. One, it lets my load balancer get up to speed so that I won't have bottlenecking or issues with dropping requests because my load balancer couldn't handle the load. And it also, when I'm at 90%, if I start seeing failures, I still have, or this is at 10%, if I see failures with 10%, 90% of my traffic is still okay because they're on the old environment. So it's a way to make sure that your environment isn't having issues before you fully swap over. And then once you're fully over and you're confident that this is okay, you could then terminate your old stack. Does that make sense? Okay, so weighted. Yes?
So the weighted values, you can change those through a script or programmatically on the fly, or is it through the interface?
You should be able to do it through the CLI, the SDK, or the console.
Okay. Cool.
Okay, that's weighted. Latency. Let's say I have 2 EC2 instances. Let's say this here is in Ohio, and that's US East 2. Okay, and then this is in Sydney. I don't remember what, it's not US East, I don't remember the region for this one, but I am here, and let's say I'm in New York. All right. With a latency-based routing policy, I come in and I say I want I trigger a response or a request to one of these machines. Then what happens is the Route 53 will say, okay, which one's going to be faster to service this? Well, it's going to take 20 milliseconds for Ohio, and it might take 600 milliseconds from Sydney. I'm going to route them to Ohio because that's going to take less time. But somebody in South Africa might come in, do the same thing, and it's going to evaluate for them. For them, it might be 100 milliseconds and 800 milliseconds. So it's going to route them here to Sydney. So it's about how quickly can we, what's the performance impact of routing people. So latency policies check which will be quicker, and then route people via the route that will be faster. Yes?
That's determination of how long it takes to get to either of those places. Is that done ahead of time and stored, or is that done as the request comes in, so then they have to go figure out how long it's going to take and then make a decision right then and there?
As far as I understand, when the first one's done, it checks how long it takes, and I think it caches it for a little while after that,
Okay.
but don't quote me on that.
So not every single request coming in, it'll have to say, let me go check and see what all the availabilities are.
I believe so. I believe it says, it makes the check, and then it says, okay, I know this is going to be faster, I'm just going to continue to route you there. Questions? Any other questions? Okay. Is the camera working okay? Okay, next. I didn't mean to erase that part. All right. Failover. Okay, so a failover. This will check based on a health check if the endpoint you're routing to is healthy, and if not, it will route you to another failover point. So I might have 2 EC2 instances. And let's say this is my primary and my failover. So I have a health check that's maybe checking /API/ health check. And it's looking for 200. This health check is being run and ensuring that the primary instance is still operating correctly so that it's getting the proper response back. However, if something causes this health check to fail, it will say, Route 53 says, I can no longer route traffic to here, and I have configured my other failover endpoint to be here. So instead of going here, now I'm just going to route people to my failover because my health check is no longer passing. Does that make sense? Questions? Okay. And then the last type, gotta stop erasing that part.
Can you combine these, like latency and failover together?
I only have one.
Okay.
As far as I know. Now you can have multiple endpoints, but I don't know of any scenario in which you could say, I want a weighted and latency.
Right, that makes sense.
Geolocation. So, this might say, I have different users, and I'm from the US, and I have somebody from,
Russia.
sure.
From Mother Russia.
And let's say, the UK. And let's say that I have instances, I have traffic, let's say I have an EC2 here in Ohio, I have an EC2 in London. When I come in, I will go here and it says, oh, I know that this person is from the US. Therefore, I want to route them to the instance in Ohio. Oh, Russia. Well, I'm going to come here, but I might have a block rule. Block. Russia. Since the origin is from Russia, Route 53 will not let that through. UK says, oh, I know you're from the UK, which means I'm going to route you to the London instance. This could be important because the different environments you have may be may have different content, may have different ways of routing. So, for instance, if you're processing transactions, you might have to process them differently. You may have everything listed in pounds, or you may have products that may be specific to London, and you may have products that are specific to the US. And you also may want to just blatantly block access from a certain country. Does that make sense? Questions?
Does that still work if they're using like a VPN or something?
The VPN, so the question was, would that work still if they're using a VPN? And no, because the VPN would be what triggers traffic. So if a person from Russia is using a VPN into the UK, it's going to appear that they're from, that request originates from the UK.
Can you route based on state or province?
The question is, can you route based on state or province? I don't know. Honestly, I don't know if it's that granular. That'd be I don't. Yeah, that's a really fine grained check. So I don't know. No questions? Okay.
Are TLS SSL certs covered in the developer exam?
So the question is, are the TLS SSL certs covered in the developer exam? The scope of it that I know of is pertaining to how many certs you can have on an ELB. That's it. And you can have one and only one SSL cert on an ELB. If you need multiple certs, you can use star certs, but you can only attach one cert to an ELB. That's about the scope that I know of for the developer exam. Any other questions? All right, that's the end of this, guys. Next steps. Go out and study any of the unclear topics. The goal of this was to get you guys like 80% of the way there. There is great learning platforms out there. A Cloud Guru and Linux Academy were the two that I used. A Cloud Guru is great at explaining things, and Linux Academy's practice exams are phenomenal. Then there's also an AWS practice exam. It's on the link that's provided. It's $20 for the practice exam, and it's in the format that you will take in your exam itself. And then finally go out and schedule your exam. I'm going to open it up for any questions on any topics.
Do they host the exams like periodically in a particular city, or?
So you would go to the website, and then when you schedule your exam, there's different testing centers that you would register at, and I think you can register up to 24 hours or 72 hours ahead of time. But you can go in once it's scheduled. There's no like only certain days. You can just go in and schedule it and take your exam then, and it's at those testing centers. And those testing centers are all over the place. In our case, there's one just down the road.
What's the approximate length of an average exam?
So this exam was 80 minutes. And when I took it, I think it was like 55 questions. Okay. Any other questions? Over anything? Okay. I will send out the slides. I will send out the sample. I gotta find it, but I'll send out the sample Cloud Formation script and the ELB, or sorry, not the ELB, the VPC diagram. And then also, I'll be sending out an email with a SurveyMonkey on it. If you guys could fill that out for me, please. This was my first time doing this. I'd like feedback. I know that there's room to improve, so anything that you can help me with on that would be greatly appreciated. If there are no further questions, then best of luck. Thank you.